Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, new topic, last topic of Module 4, new photo. That is the town of Mota, Santa Anastasia, which is in Sicily, and that is Mount Etna behind it. Just beautiful. And now I'm going to ruin the picture. Sorry about that. Okay, lesson 12, dividing segments proportionately. Okay. Now I put this here because I want to explain midpoint using this diagram. So exercise says find the midpoint of ST. So we know what midpoints are, but now we're going to use proportions to break it into different sized pieces. And that's what this lesson's about. So it says to find the midpoint ST, given S. So in this case, let's just cover that A and call that S, and cover up the B and call that T. And we want to find the midpoint of ST. So X1, Y1 is -2, 8, and X2, Y2 is 10, -4. So I'll label the diagram as such. So there we go. We want to find this point right here. And the midpoint is the first term, the first X plus the second X divided by 2, comma, the Y plus the other Y divided by 2. So if I were just to use this formula here, then the midpoint of ST is going to equal X1 plus X2, -2 plus 10, divided by 2, comma, Y1 plus Y2 divided by 2. Y1 is 8, Y2 is -4, 8 plus -4. And that will give me my midpoint. So when I simplify this, the midpoint of ST is going to become 10 plus a -2, or 8 over 2, comma, 8 plus a -4, which is 4 over 2. Well, that's going to simplify even further to 4, comma, 2. So this M here is the point 4, comma, 2. So if I think I have to get from -2 to 4, I have to add 6. To get from 4 to 10, I have to add 6. They have to be the same if you're in the midpoint. To get from 8 to 2, I have to subtract 6. To get from 2 to -4, I had to subtract 6. So that gives us 2 congruent segments meeting at the midpoint of ST at the point 4, 2. Now there's another formula I want to cover now, so I'm going to erase this. And there is another way we can do that. And we can say that the midpoint is X sub 1 plus the difference of the X's. What am I trying to write there? An X, I guess. Okay, so X sub 2 minus X sub 1. And then that would be divided by 2. So you can put a half out in front, but I've been doing it divided by 2 here. So I can take X sub 1 plus X sub 2 minus, comma, and then Y sub 1 plus Y sub 2 minus Y sub 1 divided by 2. So when I do this formula, watch what's going to happen. I'll change colors just to show you. X sub 1 is -2 plus X sub 2 is 10 minus X sub 1, which is -2. Careful, minus a -2 is plus 2 over 2, comma, Y sub 1 is 8 plus Y sub 2, which is -4, minus Y sub 1, that 8, divided by 2. Okay, the really cool thing here is it's going to come out to be 4, 2 again. So I'm going to get 10 minus -2 or plus 2. So it's going to be this -2 here plus 10 plus 2 is 12 over 2, comma, 8, and -4 minus 8 is 12 over 2. So then when I simplify that again, just to get rid of the fractions, I'm going to have negative 2 plus 6, comma, 8 minus 6, right? Negative 2 divided by negative 12 divided by 2 is negative 6. So this is going to come out to be negative 2 plus 6, which is 4, and 8 minus 6, which is 2. And as you can see, it equals the equation up here. Okay? All right, so why am I showing you a more difficult equation to do the same thing? Well, because. Is that good enough answer for you? If not, keep watching. This is the reason. Number 2, find the point on the directed segment from the point negative 2, 0 to 5, 8 that divides it into a ratio of 1, 2, 3. And not TWO, 1, TO, 3, 1 to 3. So if I'm going to divide something in a ratio of 1 to 3, there's going to be one segment, I did in blue, and then 3 other segments in red, totaling 4 segments. So whenever you have a ratio, you could think of it as, well, how many segments would there be if I broke that into a ratio of 1 to 3? It'd be 1 and 3, or 1 plus 3, totaling 4. Okay, so that's where we are going to figure out what number goes in the denominator when we are solving this problem. Okay, so if the endpoint of this right here is negative 2, 0, and the other endpoint we were given as 5, 8, we want to know this point here that breaks this line into a ratio of 1 to 3. So I want to know what this point right here is, the x comma y. I'm going to use this formula up here. So I'm going to say, and I'm not going to use the m because it's not a midpoint. So we just put this parenthesis here for our point, and we're doing the x first. So x sub 1, and let me just move up so we can see our formula. It's this right here. So we take our x sub 1, which is negative 2, plus, and then we're going to take x sub 2 minus x sub 1 in my numerator. X sub 2 is 5, minus x sub 1, be careful, minus a negative 2. And then we're going to divide by how many segments we want to break this thing into. And this is going to be 4, comma. Then we're going to take y sub 1, which is 0, plus y sub 2, 8, minus y sub 1, 0, divided by 4. So there's my formula substituted with the givens. And now I'm just going to simplify it. So it's going to be negative 2 plus, well, 5 minus a negative 2 is 5 plus 2, which is 7. So it's going to be 7 over 4, comma, 0 plus, well, 8 minus 0 is 8. 8 over 4 is 2. So I'm going to get the point 2 over here. So I just need to simplify this. So if 2 is 8/4, so let me just erase that little piece here. And I'm just going to change this 2 to 8 over 4 so we can add the fraction with the common denominator. So 2 is 8/4. Negative 8/4 plus 7/4 is a negative 1/4, comma, 2. So we should be at this point negative 1/4, 2. And that is the point. So if I kept doing that, if I then did it again, I would find this point, and then again this point, and then again this point. We're finding the same. So 0, I had to add 2 to get here. Add 2 to get here would be 4. Add 2 to get here would be 6. Add 2 to get here, we would get to our 8. Negative 2, I had to add 1 3/4 to get to a negative 1/4. Add 1 3/4 to negative 1/4. Let's do this with a calculator so we don't lose track of it. So let me start with negative 2 plus, and we're adding 7/4, 7 divided by 4, which is 1 3/4. And that will give us negative 1/4. And if I add 7/4 to it again, That would bring us to 1.5, which is right here, 1.5 comma 4. And then if I take 1.5 plus 7/4 again, then it would put me to 3 1/4, comma 6. And then one more time, add 7/4 to the x value, and it would bring me to 5. And there's 5. Add 2 to my 6, and that would bring me to 8. So let me just write all these in now. So I went from -1/4 to 1.5. So it'd be 1.5 comma 4. This point here, 1.5 comma 4. And then this was 3.25 comma 6. So look what's going on. 0 to 2 to 4 to 6 to 8. The y's increased by 2. -2 increased by 7/4 gets us to a -1/4. Increased by 7/4 gets us to 1.5. Increased by 7/4 or 1 1/4 brings us to 3.25. Add 1 3/4 to 3.25 and we get to 5. But the answer to this problem is right here. -1/4, comma 2. Whew. Okay, number 3 says, given a line segment PQ and a point R that lies on PQ such that point R lies 7/9 of the length of PQ from P along PQ, sketch the situation described. Okay, it's very similar to this right here. So just give me a moment and I'm going to bring that down. Okay, so here it is. Just keep in mind that these are all one piece. And I just broke them up to show you that that's where the segments are. So there's segments of this length: 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7/9 would be right here. 7 out of the 9 are on the left. So we are 7 segments of the same length away from P. And Q is down here. There are 9, so R lies 7/9 the length. So this is R. So there's our picture. 1, 2, 3, 4, 5, 6, 7. There's R. 1, 2, totaling 9 to Q. B, is R closer to P or closer to Q? And how do you know? Well, 7/9, 7 and 2 is 9. 7 is further from, R is 7 units from P. Q is 2 units from R. So that's how you know. So how would we say that? Here's how. Okay, R is closer to Q because it lies more than halfway along the segment from P. 7/9 is more than 1/2. It's a good way to put it. Okay, part B says, is point R closer to P or closer to Q? How do you know? Oh, hello, that was that. I'll be all right. Okay, page 2, number 3, I carried over to C. So I just brought this over so we could see it again. It says, use the given information to determine the following ratios. PR, well, that is 1, 2, 3, 4, 5, 6, 7 units. So let me put that 7 back there. And this is 2. And so PR is to PQ. Well, PQ is the 7 plus the 2 or 9. So the ratio of PR, 7, is to 9. RQ is 2. PQ is 9. So this would be 2 to 9. PR is 7. RQ is 2. So PR to RQ is 7 to 2. And then RQ is 2 and PR is 7. So that would be 2 to 7. D says if the coordinates of point P are 0, 0, so let's put that there, and the coordinates of point R are 14, 21, what are the coordinates of Q? What are the endpoints? So I had to come over here to get from 0 to 14, and if there are 7 of these, well, this one you can kind of do in your head. So if this is a length of 7, or it's 7 to 2, and this is a length of 14, well, 14 divided by 7 segments would be 2, 2, 2, 2, 2, 2, 2. 1, 2, 3, 4, 5, 6, 7. 7 twos. Repeated addition is multiplication, so all I would do is say, well, 2 times 7 is 14. Okay, so the coordinates of Q would be 2 more, 14, 15, 16, 17, 18, comma, and then to get here to 21, well then now these lengths are all 3, because to get 21 divided by 7 is 3. So that would mean each one of these is length of 3. 3, 6, 9, 12, 15, 18, 21, booyah. Plus 3 more is 24, plus 3 more is 27. So it's 18, comma 27. Okay, so I'll put that answer right here. 18, comma 27. Okay. Okay, so now I want to show you how to do this problem without using the diagram and drawing a diagram every time. So the numbers are really large. You don't want to sit there and draw segments and count out like I just did up here. So what are we going to do? Well, what is the formula? The formula of a point that is a ratio breaking up the segment into a ratio of something to something is the point x sub 1 plus x sub 2 minus x sub 1. And then well, actually, let me move that. Of course, erase. So some ratio AB, x sub 2 minus x sub 1, okay, comma, y sub 1 plus some scale or some ratio of something to something of y sub 2 minus y sub 1, where y sub 2 is the right end, y sub 1 is the left end. That is going to equal a point x comma y that is somewhere in between, and let's call that x sub 3, y sub 3, just for setting this equation up. So what we're going to do is, I think I might need a little more room, so let me get this robot out of the way. Okay, so here are our points. So I'm going to label this all up just so we don't make a mistake. This is x sub 1. This is y sub 1. It's the left end. The coordinate of point R is the other end point. So if I look back over my diagram, actually it's a segment PQ. If the coordinates of point P are 0, 0, and R is 14, 21, R is actually our x3, y3 we were trying to find. So this is x3, comma, y3. And the coordinates of point Q, would be our x1 or x2, comma, y2. Okay, the endpoints are 1 and 2, and the point in between I'm calling 3. So very carefully, we're now going to fill this in. So x sub 1 is 0. Plus our ratio is 7 to 9. Okay, we were told that 7/9 right there, 7 over 9. So our a over b is going to be 7 over 9, and our x sub 2 we don't know, so I'm going to just leave it x. Let's just call it x. No, I'll leave the 2 there. Minus x sub 1, which is 0, and then comma y sub 1, which is 0, plus my ratio of 7/9 times y sub 2, which we are trying to find, minus y sub 1, which is 0, is going to equal x3, y3, which is 14, comma 21. So whenever you write a formula and substitute in your givens, it is really important you do that. And so here's what's going to happen. This is all parentheses here. So 0 plus, that's just going to go away. x sub 2 minus 0 is just x sub 2, so that's going to leave us with 7/9 x sub 2, comma, this 0 goes away, this 0 goes away, y sub 2 minus 0 is just y sub 2, so it's going to be 7/9 y sub 2 equals 14, comma, 21. Okay, so what we're going to do is we're going to set this equal to that. 7/9 of some value, that's our endpoint, is 14, and 7/9 of some value, y2, is our endpoint to find 21. So now to solve this, I'm just going to split this into two equations. I'm going to say 7/9 x sub 2 equals 14. So to solve for x sub 2, I'm going to multiply by the reciprocal on both sides. And these cancel, and I get x sub 2 equals, this 7 will make that 14 at 2, and 9 times 2 is 18. So my x value is 18, comma, and then I'm going to do the same with the y's. So it's going to be 7/9 y sub 2 equals 21. Multiply both sides by the reciprocal 9/7, the inverse. These cancel. This 7 will make that 21 a 3, and we get y sub 2 equals 3 times 9, which is 27. And that is our other endpoint, 18, comma, 27. Now, if you recall, that's what we got by doing a diagram and counting. So knowing this formula and saying that this x sub 3, y sub 3 being the point in between at a certain ratio, use this equation here. It's actually pretty slick. Okay, number 4, a robot is at position A, 40, 50, and is heading toward point B, 2000, 2000, along a straight line at a constant speed. The robot will reach point B in 10 hours. What is the location at the end of the third hour? Okay, so I am going to do a diagram just to simplify this the first time, but it always helps to sketch. So we're at point A, we're going to B, so we're going to have a segment. Okay. So if this is A, and this is B, then this is the point 40, 50. And this is the point 2000, 2000. So as before, this is x sub 1, y sub 1, and this is x sub 2, y sub 2. So we know our endpoints in this problem. Okay. And what it's saying is it's going at a constant speed, and the robot will reach point B in 10 hours. So we break this up into 10 segments, and it says, what is the location at the end of the third hour? So that's a ratio of 3 to 7, or 3 out of 9, if you will. Because if we go back up here, whoops, then we said this was a ratio of 7/9. 7/9 of the way was here, so it's 7 to 2, if you will. So those are what all these ratios were. But now we're working with this one, and it's 3 to 7. Okay. But the total is 10. So the ratio that we will be using is 3/10. That is our A over B. All right. So the formula is x sub 1 plus the ratio, or the ratio, x sub 2 minus x sub 1, comma, y sub 1 plus 3/10 of x sub 2 minus x sub 1. So there it is. All right, so x sub 1 is 40 plus 3/10 x sub 2, 2000, minus x sub 1 of 40, comma, y sub 1, 50, plus 3/10 x sub 2, 2000, minus x sub I'm sorry, y's. Why do I have x's here? They're supposed to be y's. Okay, hopefully you picked up on that and didn't just sit here and copy me. All right, y sub 2 minus y sub 1. It is still 2,000, but it's minus 50. All right, so in solving this, we're going to get 40 plus 3/10 of 1,960, comma, 50, should be a 0 there, plus 3/10. 2,000 minus 50 is 1,950. Okay, so that's going to give us 40 plus this 10. We'll get rid of that 0. 6 times 3 is 18. 9 times 3 is 27. Plus 1 is 28. 3 times 1 is 3. Plus 2 is 5. Comma, 50 plus this 10. We'll get rid of this 0. 5 times 3 is 15, carry the 1. 9 times 3 is 27, plus that 1 is 28, carry the 2. 3 times 1 is 3, plus 2 is 5. So my answer is going to be 8. 8 plus 4 is 12, carry the 1. 628, comma, 5 plus 0. 8 plus 5, carry the 1. So my answer should be the point 628, comma, 635 after 3 hours. Okay, so now part B, they're getting really ridiculous on us. And they're saying, what is the location of the robot 5 minutes before it reaches point B? 5 minutes. So what ratio is that? Well, it's 10 hours. So now I have to convert that to minutes. So 10 hours times 60 minutes in an hour gives us 600 minutes. Okay. 5 minutes before 600 is 595 minutes. So we're going to be 595 out of 600. So that is my ratio for this problem, 595 over 600. So then I just redo this problem again and change that last ratio of 3/10 to 595 600ths. All right, so that was the only trick to this problem, converting hours to minutes and knowing how many 5 minutes less than total. Okay, so what's the location of the robot 5 minutes before it reaches point B? So that'd be the point 595 600ths away from x sub 1, y sub 1. So we're going to plug that in. X sub 1 is 40 plus 595 over 600 times x sub 2 minus x sub 1, comma, y sub 1 plus 595 over 600 times y sub 2 minus y sub 1. Okay, so this is going to give us 40 plus 595 over 600. And if you did this before and didn't erase it like me, you could just copy 2,000 minus 40 is 1,960. And then comma 50 plus 595 over 600, 1950. Okay. Now we have to calculate this mess. So I'm going to use a calculator to do this just to save time. On, clear, order of operations. Actually, I can just do this. 40 plus, and then in parentheses, 595 divided by 600. Close the parentheses and put 1960 after it, and that'll give us our x. So that's going to be 1983 and 2/3. 1,983 and 2/3, comma, and then do the same for the next one. 50 plus parentheses 595 divides 600, close parentheses, and it's 1950. And that gives us 1983 3/4. Okay, 1983 3/4. So there is the location 5 minutes before it gets to 2000. Okay, we're still talking about this robot on page 3, part C. Now it says if the robot keeps moving along the straight path at the same constant speed as it passes through point B, this 2000, what will be its location at the 12th hour? So that would change our ratio now to 12/10. So if we had a point here and a point here, then going the full distance is a ratio of 10/10, the whole thing. If we go one less, that'd be 9/10. But if we go 2 over, then our numerator is greater than our denominator. So the whole thing is greater than the original total, which was this endpoint B, 2000. Okay, so this is our ratio we're going to work with. So the formula is x1 plus our ratio 12/10 times x2 minus x1, comma, y1 plus our ratio y2 minus y1. And that is going to give us the point beyond the 2000, which is here. This is 2000 right here. Think of it as continuing on for 2 more hours. Okay, 12th hour. So this is going to give us 40 plus 12/10 times 2000 minus 40 is 1960, comma, 50 plus 12/10, and 2000 minus 50 is 1950. So this is going to be 40 plus, this 10 will make that 196. So let's just use the calculator. 196 times 12 is 2,352, comma, 50 plus, and then I'm going to take 10, we'll make that 195, and 12 times 195 equals 2340. So when I add these, I'm going to get a 2 here. 5 and 4 is 9, 3, 2, and then 0 plus 0 is 0. 4 plus 5 is 9, 3, 2. So the answer is 2,392, 2,390. Okay. D says compare the value of compare the value of the abscissa, the x-coordinate, to the ordinate, the y-coordinate, before, at, and after the robot passes point B. So if I go back, I think I might have erased it. So I'll just bring in what they have printed. Okay, so we'd say initially the abscissa, or the x-coordinate, was less than the ordinate, the y value. As the robot moved towards point B, these values got closer to being equal. At point B, they were equal. And for all points on the path beyond point B, the y-coordinate was less than the x-coordinate. Okay, E. Could you have predicted the relationship that you notice in part D based on the coordinates of point A and B? Question mark. Okay, this is a really long answer. You might want to paraphrase here, but the answer is yes. If point A was located at the origin, the path that the robot took would have been described by the equation y equals x. Then at each location the robot occupied, the x and y coordinates would have been equal. Point A actually lies above the origin, making the slope of the line that describes the robot's actual path less than 1. Initially, the y coordinate of each point, the location, is greater than the x coordinate because the line has a y-intercept greater than 0. The slope of the line is less than 1, so as the robot moves to the right, the gap closes because for each unit the robot moves to the right, it moves less than 1 unit up. When the robot reaches the point B, which is 2000, 2000, the abscissa, x-coordinate, and the ordinate, y-coordinate, are equal. Beyond point B, the x-coordinate will be greater than the y-coordinate. Hopefully you got that. Okay, page 4 brings us to the end of lesson 12. Go do your problem set.